Mr. Clelland here for Clelland Maths. So today we're doing National 5 Maths Scientific Notation. Quite a lot of people find this one quite tricky. So strap in for this one and hopefully we'll get through it together. Just a reminder, a lot of these examples are taken from maths.scot, which is an excellent website. And obviously we're developing an app as well, if you've not noticed. So a lot of this stuff's going to go on an app that you can work through together yourself and then get the answer straight away. So hopefully look out for that at the end of the month. But example 1, express 51,600,000 in scientific notation. So a big number to scientific notation means I just write down 5. The first number I come to 0.16 because the first number needs to be between 1 and 10. Then it's just a bunch of zeros, so it's times 10. And then to get your power, you just count how many numbers are after the first one. Well, I've got 3, 6, 7. So it's the power of 7. And we're done there. Example 2. Express this small number in standard form. Standard form is the same as scientific notation if you see it. So again, we just go along till we reach the first number, which is 7. Write a point straight away. The rest is 081, because then it doesn't cut into a bunch of zeros. It's still times 10, but with a small number, it's a negative power. Now, what you want to think about is, I'll give you a trick in a minute, but really what's happening is that this point is going 1, 2, 3, 4, 5. 5 places I need to go, so minus 5. If you don't want to think of it as jumping though, one trick that always works is count how many zeros are in front of the first number. 1, 2, 3, 4, 5, minus 5. Nice little trick there, and you're done.
Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClellandMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClellandMaths to get 30% off that. Link down below.
Example 3. Evaluate 4 times 10 to the 14 divided by 8 times 10 to the 6. Give your answer in scientific notation. Well, a question like this means you can just do the number part, 4 divided by 8, and then the scientific notation part with powers using laws of indices. Check a link in the description for that, and then combine it. So let's do 4 divided by 8 first. Well, that's just a half. So that's just 0.5. So I'll keep that in mind. And then I've got 10, 14 divided by 10, 6. Well, laws of indices say I take away the powers. So 14 minus 6 is 8. So it's 10, 8. So really I could say I've got 0.5 times 10 to the 8. However, that's not scientific notation because the first number has to be between 1 and 10. So I'll change that one to 5. Times 10 to the minus 1, and I've still got 10 to the 8. So I can now just combine that by adding the powers. 8 minus 1 is 7, 10 to the 7, and we're done there. Example 4 for scientific notation. In the year 2015, they were estimated to be 7.34 times 10 to the 9 people and 3.04 times 10 to the 12 trees in the world. Calculate the number of trees per person in 2015. Express your answer corrected to significant figures. So this is where people start to get a little bit tricky because they'll translate this into a times or divide sum. Well, it says calculate the number of trees per person. So I need 1 person. So all I need to do, think about here, is if I've got that many people and I want to know for 1 person, I need to divide by this number to get 1. So that's it. It's 3.04 times 10 to the 12 divided by 7.34 times 10 to the 9. So I need to get my calculator. Now, in my calculator, I put 3.04 and then I press EXP to get times 10 to the power and then 12. In other calculators, it's like a times 10 with a power button. But in any case, you would get this. Now, I would advise you put brackets around any numbers in scientific notation so that your calculator doesn't mess you up, because sometimes we do. So I'll put it in brackets and then divide, and then brackets, 7.34 exponential 9, close my bracket, and it gives me an answer. So the answer is 414.1689, and it goes on for a while, so I'll put ... Two significant figures means the second number. So that's 4, 1 rounds down because the 4 next to it, so that's 1, and then 0 filling in up to the point, 410, and we're done there. Example 5. The average adult has approximately 7.6 times 10 to the 6 white blood cells per milliliter of blood. On average, an adult has 5.2 litres of blood. Calculate the average number of white blood cells in an adult body. So we've got thinking in it like this. We've got some white blood cells per milliliter. So if I wanted to know per litre, I would times by 1,000. And then I want to know per 5.2 litres, so I need to times by 5.2. Remember, we also have a members only, £4.99 per month if you want some regular live streams and that extra boost. But let's go into this, 7.6 times 10 to the 6. Now we're timesing by 1,000 to get a litre, and then 5.2. So there we are, 7.6 times 10 to the 6, 7.6 exponential 6, times 1,000, times 5.2, gives us 3.952 times 10 to the power of 10. Now, if your calculator is big enough that it can display the whole number, you will have to change it to scientific notation yourself. But it then says one significant figure. Well, that's just the first number I come to, so 9 rounds up to 4. So it's 4 times 10 to the power of 10. And we're done there.
Couple of past paper questions standard form. So 2016 paper 2 question 2. A pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Calculate the weight of one pollen grain in grams. Give your answer in scientific notation. So it's asking for the weight of one of the things. So I need to divide by 1.5 times 10 to the 9 to find one of them. So the sum I'm going to do is 12 divided by 1.5 times 10 to the 9. And I'll put that in brackets to remind myself that when I get my calculator out, I'll need to use a brackets around it. So that's 12 divided by 1.5 to the power times 10 to the power of 9. That gives me 0.0000000008. So I just write that down. 0.0000000008. I have to give my answer in scientific notation or standard form. So I just do that in the same way. 8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 9. SQA National 5 Maths 2019 Paper 2 Question 4 Scientific Notation or Standard Form. A sesame seed weighs 3.6 times 10 to the minus 6. The weight of a poppy seed is 8% the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms. Give your answer in scientific notation. So in other words, I need to work out 8% of 3.6 times 10 to the minus 6. So in a calculator, I can do 8 times that and then divide by 100, or just do 0.08, because that's 8%, times 3.6 times 10 to the minus 6. Now, when you do that in your calculator, you might get an answer of 0.000000288. Or if you're lucky, your calculator will give you it in scientific notation. But let's assume it didn't, and it didn't give us this answer. We change that to scientific notation. So our first number is 2, so it's 2.88 times 10 to the power of minus, because it's a number which less than 1. And to get that, we imagine our points here. It's 1, 2, 3, 4, 5, 6, 7. Minus 7. And it's kilograms for our units. And we're done there. SQA National 5 Maths 2021 Paper 2 Question 2. Light travels at 3 times 10 to the power of 8 metres per second. A star is 4.2 times 10 to the 17 metres away. Calculate the number of seconds it takes for the light from the star to reach Earth. Give your answer in scientific notation. So first of all, you have to kind of pull out what's it asking me. So let's just look at each individual line. Light travels at something metres per second. Metres per second is speed, so let's write down speed. 3 times 10 to the 8 metres per second. Next line says a star is something metres away. Metres away. Metres is distance. So I've got a distance. And that equals 4.2 times 10 to the 17 metres. And then it says, calculate the number of seconds it takes for light to reach the Earth. Calculate the number of seconds. Time. I have to work out a time.
So time is my missing num thing. So if you don't know, this is a distance, speed, time question. I've got distance, speed, and time in the question. So I can write a triangle: distance, speed, time. And to work out what time is, if you don't know, time is this one. So I've got leftover distance divided by speed. So I can immediately write down that time is distance divided by speed, and sub in these big numbers, even though they're huge, right? So the distance is 4.2 times 10 to the 17 divided by 3 times 10 to the 8. And it's a calculator job, so we need to know how to put that in a calculator. So 4.2, now either be a times 10 with a power button on your calculator, or it'll just be EXP. And mine's it's EXP, so I just press EXP and then 17, and that means 4.2 times 10 to the 17, and that's getting divided by, now I'll use brackets to make sure it doesn't mess me up, 3 EXP 8. 3 times 10 to the power 8. And it gives me an answer, and if you're lucky, your calculator will give you your answer in scientific notation, and if it doesn't, write down the answer you get and then convert it yourself. So I'm going to write down the answer I got, making sure I don't miss any zeros. So I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros after that. 1, 2, 3, 4, 5, 6, 7, 8 seconds. So now I need to convert that myself into scientific notation, which is a good thing for this video, but normally your calculator will probably do this for you. But just to remind you, I take the first number, 1, then it's just point. The next number, 4, there's no other number, so I'm done there. 1.4 times 10, I need a power. To get my power, just start counting at the first number after the 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. To the power of 9, and the units are seconds, and we're done there. Check I've answered the question. I've done it. Job done. Okay, scientific notation, SQA National 5 Maths 2023, paper 2, question 2. The mass of helium atom is 6.64 times 10 to the minus 24. A flask contains 300 grams of this helium. Calculate the number of atoms in the flask. Give your answer in scientific notation, correct to 3 significant figures. So sometimes it can be hard to work out exactly what to do with these questions. So sometimes I just use a number for this to see what sum would I do if it was just a normal number. So let's just imagine that this number was 2. The mass of a helium atom is 2 grams, and I've got 300 grams of these. How many atoms do I have? Well, that's 150, because 2 times 150 is 300, or conversely, I've done 300 divided by 2, and that tells me the number. So I'll just do the same trick now, but use this number instead, and use a calculator. So I'm going to do 300 divided by this number, and hopefully you can see how I worked out I needed to divide. So step 1, I write down my sum, 300 divided by 6.64 times 10 to the minus 24. Using a calculator, 300 divided by, I'll open a bracket, 6.64, exponential for me, that's e, that means times 10 to the power of, and then it's a negative 24. So if I've done that right, I can close my brackets. I get an answer which is 45.181. So I'm going to write 45.181, and there's a bunch of other numbers, but I've rounded it there, times 10 to the 24. So I know that there's 45.181 times 10 to the 24. Now, my calculator was a bit weird and did that. Your calculator might have given you it as a 4.5181, and it would say, well, let's say we had to convert that. I've divided by 10, so my times 10 has to go up by a power, times 10 to the 25. So now the last step says, give your answer in scientific notation, which it is, but to 3 significant figures. So 3 significant figures are 1, 2, 3, round there. So that means that I'm rounding at this point. So I can just do 4.5 round up to 2 times 10 to the 25. And I'm done there. Now just double check your answer. SQA National 5 Maths 2024, paper 2, question 2. An ant colony occupies an area of 50 hectares, and there's an average of 1.22 times 10 to the 6 ants per hectare, so in 1 hectare. Calculate the number of ants in the colony. Well, the ant colony occupies an area of 250 hectares. That's per hectare, so it's just times 250. Times 250. Now, your answer is to be in scientific notation, but it might give you it without scientific notation to start with. So then I change that by writing 3.05 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 3. The mass of 1 atom of gold is 3.27 times 10 to the minus 22 grams. The mass of 1 atom of carbon is 6.1% of the mass of an atom of gold. So we know the mass of an atom of gold. We have to look at the mass of an atom of carbon. So it's just 6.1% of 3.27 times 10 to the minus 22. So in a calculator to do that, I just do 6.1 divided by 100 times 3.27 to the power of minus 22. And it gives me an answer of 1.9947 times 10 to the minus 23 grams. Now I could maybe round that if I want to about 2 or 1.99, but unrounding it doesn't make a difference because you're not getting asked to round. So we're done there. This is Mr. Clelland for Clelland Maths. Today we did the whole of scientific notation in National 5 Maths. Hopefully you found that useful. Take care, stay safe, and goodbye.